Cameron Iron Works had its beginning at Houston, Texas in 1920 as an oil field repair shop. Today, its headquarters is located on a tract of approximately 100 acres, with over 30 acres under roof. These buildings include machine and assembly shops, engineering and metallurgical laboratories, design departments, sales, and general offices. Cameron is almost a self-sufficient manufacturer. With facilities that include two 25-ton electric furnaces, a 40-ton vacuum melt furnace, degassing equipment, and soaking pits. And in addition, 12 consumable vacuum remelt furnaces to assure highest quality alloys for Cameron pressure control products and Cameron custom forgings. With the metallurgical knowledge and the forging technology available in the Special Products Division of Cameron, it is now possible to completely eliminate sand cracks, inclusions, and crevices that heretofore have plagued metal manufacturers relying on cast bodies and parts. Cameron manufactures its own tools and dies. Cameron forging equipment consists of hammer forges that forge small valve bodies, balls, and parts. Cameron's 4,000-ton press with sliding platen, forging a pump liner. Cameron's 5,000-ton press, forging a breech block for the military, making use of side rams. Cameron's 11,000-ton press, forging a 13,500-pound throttle valve body, utilizing the multiple ram split die forging technique. A 20,000-ton press, the world's largest split-die down-acting forging press. Forging high-pressure pipe for nuclear power plants. All of these presses produce forgings with uniform high strength and toughness, attainable only by this process. Complete heat treating facilities with precision temperature control ensure the combination of mechanical properties specified by the designer. Multiple action, automatic, and electrically controlled machine tools shape forgings to close tolerances. To assure uniform high strength, the Type U blowout preventer body is forged from a hot billet by Cameron's split die multiple ram press forging process. Both halves of the die are closed, partially shaping the metal. Then the side rams move in, forcing the metal to completely fill the die cavity. are shaped during the forging operation, which reduces the amount of machining required. The preventer body is placed on a horizontal boring mill, and bonnet faces are machined. When preventers containing multiple ram units are required, 2 or more ram unit body forgings are joined by an automatic welding machine. And end connections are welded on. The ram bore is finish machined on a horizontal boring mill. Holes for bonnet bolts are drilled and tapped in the preventer body. Bonnets are finish machined. The inside surface of the ram operating cylinders is ground to a smooth finish. One of the operations in finishing ram chain cylinders is machining of the O-ring grooves. The ram forgings are also machined. A cutaway of this 6-inch, 5,000 psi Type U preventer shows the vertical bore, the rams, and the hydraulic operating system. Also shown are the O-ring seals on the ram chain cylinders and on the ram operating piston. The fitting, where plastic packing can be injected to back up the lip seal, thus providing triple protection against leakage along the piston rod. The path of hydraulic fluid through the ram open circuit to the ram operating piston. The path of hydraulic fluid through the ram closed circuit to the opposite side of the ram operating piston. As the rams close, the self-feeding ram packing seals between ram faces. Well pressure assists in closing the rams and holding them closed. A typical blowout preventer stack may consist of a lower preventer unit, a drilling spool with side outlets, to which is attached the choke manifold with hydraulically operated gate valve and kill line connections. The height of the preventer stack may be reduced by omitting drilling spools and connecting the choke manifold to a preventer side outlet. An intermediate preventer, which may be single or double, The top preventer may be either a ram type or annular type. A bell nipple with side outlets for fill-up and mud returns is connected to the top of the preventer. The top preventer is equipped with remote-controlled hydraulic wedge locks, originally designed for underwater service. They operate positively and rapidly, so much so that they are today being used on many land installations. The Type U preventer is designed so it may be completely reconditioned by drilling crew members without removing it from the well. Worn parts can be replaced with a minimum of rig time and expense. First, the 4 bonnet bolts are backed off. Hydraulic pressure applied to the ram close connection opens the bonnets, so the rams are readily accessible. An eye bolt is screwed into the ram, and it is easily lifted out. Access to the operating cylinder and ram change cylinders is gained by removing the cap screws that join the intermediate flange to the bonnet. And separating the bonnet from the intermediate flange, with the bonnet removed, ram change cylinders are easily removed from the intermediate flange. O-rings, which pack off ram change cylinders in intermediate flange and bonnet, are easily replaced. The ram operating cylinder is slipped out of the intermediate flange. And when necessary, O-rings can be replaced. The operating piston is slipped out of the intermediate flange. Note that one ram change piston has a hole in the end, and the other one has holes drilled radially through the rod. Ram change pistons are unscrewed from the preventer body and are removed. To repack a ram, the top seal is first removed. Note that it has locking pins, which hold the ram packer firmly in place. After the top seal is removed, the ram packer is slipped out and a new one inserted. Installation of the top seal locks the packer in place. The procedure for assembling the Type U preventer is exactly reverse of taking it apart. Ends of ram change pistons are passed through holes in the intermediate flange and are screwed into the preventer body. Correct installation is assured by different sized threads on each piston. The operating piston is inserted. Then the ram change cylinders, followed by the ram operating cylinder. The bonnet is fitted over the operating and ram change cylinders and is then moved into position against the intermediate flange, where it is secured by cap screws. The ram is placed in position and the eye bolt is removed. Hydraulic pressure applied to the ram open connection closes the bonnets tightly and energizes the bonnet seal. So the bonnet bolts are needed only to hold the bonnet securely in place. Hydraulic pressure, which closes the bonnets, also keeps the rams retracted, away from the well bore. Cameron Type U preventers provide the maximum of dependability and ease of maintenance, as well as saving money and safeguarding lives and property by preventing such costly occurrences as this, or this, or this, or this.